Hello guys, I welcome you to Ashutosh Academy. Let's study hybridization today and how you're going to determine the geometry of the given compound. Okay, the method is, we'll just directly jump to the method. It's a bit calculative. So the first step that you need to do is you need to calculate the total valence electrons. Okay, total valence electrons. I'll do the example side by side because of example only you'll understand. Suppose you have SO3 2 minus here. Okay, so you're gonna put this as A. A is how much? A is what? A is total valence electrons. So first we'll calculate the total valence electrons present in this whole thing. So sulfur's atomic number is what? You must be knowing by now. It's 16. Okay, you'll write it as 2 8 6. And what about oxygen? It is at atomic number 8 2, 6. So valence electrons are 6 here and 6 here. So sulfur's valence electron is 6 plus 3 times, because 3 oxygen atoms are present, we'll take it as 3 into 6, and it's going to give you 24. Okay, this was our first step. So next step, what are we doing? I hope you know that we are dealing out with the geometry of this compound, how this compound is going to look like in the space. So the next step would be you are going to subtract from A the charge which is present on the whole compound, covalent compound. So it should be B now. We'll take it as B. So let's calculate B here. B is going to be A minus the charge which is present. And here the charge is minus 2. Okay, so it should be 24 minus of minus 2, that is 26. You've got the value of B? Okay, great. Now here are two cases. First, either you'll get B to be less than or equal to 8, or it will be greater than 8. So first step, you'll see here, if it is greater than, I'm so sorry, I've written it a little bit wrong. Let me erase this from here. Okay, it is, what I was saying was, B is either going to be less than or equal to 8, and in another case it will be greater than 8. Okay, if it is this case, then what are you going to do is simply divide B by 2, and that will give you the hybrid orbitals. Okay, but here it's a little bit complicated. What you have to do is divide B by 8, and you will get some quotient here, and after doing all the division part, you'll reach at the end point, that will be the remainder. But how are you going to find out the number of hybrid? This is number of hybrid orbitals. Okay, and here the number of hybrid orbitals is calculated by quotient plus remainder by 2. You are going to divide remainder by 2 first, and then add it to quotient. That will be the number of hybrid orbitals. So now can you tell me, this is which case? We've got B to be 26, and you can see that B is greater than 8. So we are going to divide 26 by 8 here, and what are we going to get? We are going to get as 3 here, 24, and it's going to give you 2. So the number of hybrid orbitals is 3, that is the quotient, plus remainder by 2, which is coming out to be 1. Okay, I hope it's clear to you, because we are doing it side by side with the example. And now if you're asked to find out the lone pairs, number of lone pairs, okay, number of lone pairs here, and the number of lone pairs is simple. It is simply dividing B by 2 plus adding it to 1, and then subtracting the number of atoms here. Okay, but in this case, that is the case 2, here number of lone pairs is equal to simply half of remainder, and it's going to give you the number of lone pairs. So we were dealing out with case 2 here. The number of lone pairs is going to be half of remainder, that is 2, that is 1. Now you've got number of lone pairs as 1. So we'll see, I'll draw the table also for the geometry, but before that we just need to find out the hybrid orbitals and the lone pairs of the given compound. So since we've got this value, this is, I'm so sorry, this is 4. Okay, I hope you've corrected it. It's 4 here, and then we'll see the structure. And this 4 is going to be how much? Simply sp3. Okay, why sp3? Because s to the power 1, p 3 orbitals, and then okay, it's showing 3 plus 1, that is 4. This is how we calculate the geometry, and we'll see the structure in my next video. Let's take another example. Okay, example number 2, and it should be I'll take a little bit easier one. Let's take H3O plus. Okay, now how you're going to solve this? First you're going to calculate A. What should be the value of A here? A was what? A was the total valence electrons present in the compound. Here it is total valence electrons. Hydrogen has 1 valence electron, so 3 times 1 plus oxygen has how many valence electrons? That was 6. So it will come out to be 9. And B was calculated subtracting charge from A, that, and here the charge is plus 1. Okay, this plus sign shows that there is a plus 1 charge present, so it's coming out to be 9 minus 1, that is 8. Since this is the case 1, case 1 was what? Case 1 was if B is less than or equal to 8. So the hybrid orbitals, number of hybrid orbitals is going to be equal to B by 2, that is 4, 8 by 2, and it's coming out to be 4 here. And how many lone pairs it's gonna have? Let's see. Number of lone pairs is equal to, what was the formula? It was number of hybrid orbitals, and then adding it 1 to it, then subtracting the number of atoms. Okay, so here the number of hybrid orbitals is 4 plus 1 minus how many atoms are present? Can you calculate? 3 hydrogen atom and 1 oxygen atom, that is 4 atoms present. So you are subtracting 4 here, you will get as 1. So what should be the structure? Okay, since you got it as 4 and 1 lone pair, so the structure will be what? Its hybridization is going to be sp3 hybridized, and I'll tell you the table. After seeing that table, you'll be easily predicting the geometry, the shape, angle, and shape and lone pairs hybridization. Everything you'll be able to see in that video. Okay, let's okay, thanks for watching, and please subscribe to my channel to watch other videos, and please give your comments, and then only I'll get to know that are you understanding my videos. Thanks for watching.